because from here only definitions will come. In fact, you know the definitions also. So first one is descriptive statistics. For that we have to know some definition. What is population, sample, process, that things. So before defining that, suppose we want to measure average height of the kid university student. So almost there are 20,000 students. So individually, if we take the height and take the average, it will take lots of time. So what we will do? Arbitrarily, we will take, suppose 100 students from each department, civil, mechanical, electrical, computer science. So we will take the average height of the students, then again we will find the average. So practically, if we take height of individual 20,000 students, the job is difficult. At a time there, now look at this situation, not all students are present here, only 5th and 3rd and 4th year. So that's why taking height of each student is difficult. So arbitrarily we will pick some students from each department. So this total student of KIT University, that thing is population. And suppose we are picking total 500 students from all the department. That thing, whatever 500 students we are taking, that thing is called sample. So idea about population and sample is clear.
Yes, sir.
Scientists and engineering are depends on collection of facts or data, mainly focused on well-defined collection of objects. Many things are written. So a large number of well-defined object or data from which observation or investigation is to be done is called population. So well-defined object or data from which observation in or investigation is to be done is called population. Here total student is the population. And suppose we are picking 500 students. That thing is sample. So a small amount of object or data is selected from the population that carries the behavior of the population is called sample. So clearly, sample is subset of the population. So population and sample concept is clear. Hello.
Yes, sir.
Okay. Then here one example is given. Let is size of train arbitrary screws are selected from a lot of 1,000 screws to study the defectiveness. Then what is the population size? Total number of screws, that is 1,000. Population size is 1,000. Sample size is 10. Okay. Now whatever collection we are taking, that thing is called data. So now we will define variable. So population sample concept is okay.
Yes. Yes.
Now we will define variables. So that is basically a characteristics. A variable is any characteristics whose value may change from one object to another in the population. A variable is any character. Suppose height of the student. So height. Some student height is 5'6", 5.5. Someone 5.4. For some student 5.5 again. For some 5.3. Some 5.1. That way. So a variable is any characteristics whose value may change from one object to another in the population. Suppose height of a student. Wait. Unable to reload. Yeah, हो गया. हाँ. Suppose height a student. Suppose that thing is x. For different student value will be different. For someone it is 5, someone is 5.1, someone again 5, for someone it is 5.2, 5.8, that way. So height is a variable. Is that okay? What is variable?
Yes, sir. Yes, sir.
So that way we can enlist the height. Now suppose height and weight of a student. So that is one thing. Height and weight of a student. Suppose that is, so how many variables required for this? Height and weight.
Two.
Two variables. Suppose x is the height, y is the weight. Then how we can, so xy takes the values. Suppose for 5 food it is say 55 kg. Suppose 5.1 it is 58. That way we can enlist it. So depending on the number of variable, we can classify it also, classify the data. Okay. See here, variable is any characteristic whose value may change from one object to another in the population. For a company, variable XYZ are brand of the object. Y is the quality of the object, Z is the number of defective objects. So here that way we can define variable. So here height, weight, that way. Sometimes we can include height, weight, age. So many variables we can take. Now depending on the number of observations, actually it is divided into two categories, although means univariate and multivariate. So when the observations are made on a single variable, the data set is called an univariate data. Only height of the students. So only one variable is there. Only one type of observation is there. That's why it is single variable or unit variable or univariate. So when observations are on a single variable, the data set is called an univariate data. So height of a student, that is univariate data. And bivariate means when observations are made on two variables, height and weight of kid university student. So that is a bivariate data. And multivariate means more than one. Bivariate is also a, we can include multivariate case also, but by most of the time we will use two variables. That's why bivariate is written here. But mainly two types: univariate data and multivariate data. Univariate means that is on only data is made on only one variable. That is univariate. If it is more than one, then multivariate. So univariate data, there will be only one variable. Here example is given. The sample of pulse rate, heartbeats per minute, for the patients recently admitted to an ICU is in numerical univariate data. So heartbeat suppose means pulse 85, 81, 80, that way it is given. That is univariate data. So univariate data definition is okay? Hello?
Yes. Yes, sir.
Yes, sir. Yes, sir.
And multivariate means more than one. Height, weight. Suppose we are taking height, weight and age. Height, weight and age. Okay. Student. So suppose we are taking x, y, z. So that is a multivariate data. In fact, trivariate this one. Okay, suppose height 5 foot, suppose weight say 53, age suppose 20. Suppose 5.1, 55, age 19. That way we can enlist it. That is a multivariate data. Okay. So univariate and multivariate data concept is okay.
Yes, sir.
Yes. Yes, sir.
See, when the observations are made on each of two variables, the data is called bivariate. Here one example is given. Sample of saturation, so means for the patient is a bivariate data. And multivariate means more than one. So although bivariate is also is a multivariate, but it is required most of the time. That's why it is specified. Nothing else. Okay. In fact, it will be invariate data. So x1, x2, xn. That way we can write. So basically, bivariate, that is a order pair xy. Trivariate xyz. Invariate x1, x1, x2, xn. That way we can write. For univariate data, we will write this x is univariate. Some xy, that is for bivariate. Invariate, it will be x1, x2, that is up to xn. That is invariate. N tuples. This is order pair. This is only single. So that way data are classified. So classification of data in this sense clear in terms of variable.
Yes, sir.
Yes, sir.
After this class, I will share handwritten notes. Means not this class. This you go through this one. Next class, I will start probability portion. Then I will share my own handwritten notes.
Okay, sir.
Okay, so these are basic definitions only. Okay, and no long questions will be there. Just simple definition, simple things will be there. Now suppose whatever data is given. So suppose height of 20,000 student. So writing, suppose it is given height of 1,000 or 1,000 students. So writing that thing is, we can write that thing. But one thing, if we want to find something, first thing is we have to write them in a order. We have to write them in a order. In that case, it is easy to find many things. Suppose we want to find the average height. So say total 1,000 student. Okay. So suppose their heights are say 5 to 6 foot. So 5 to 6 foot in this range. So what we can do? We can collect students whose are number of students whose height is 5, number of students whose height is 5.1, then 5.2, that way up to 5.9, and that is 6 foot. Suppose say that is M1 student has height 5, M2, M3, that way say 5 to 6, M11. Okay. Somehow if we arrange them, then finding the things are difficult. See, suppose we want to average height. Then we have to add all those 1000 students height divided by 1000. But if we group this way, then what will be the average height? 5
The sum of
M1,
heights divided by 1000.
5.1 M2, that way 6 M11 divided by 1000. 1000 means M1 plus M2 plus M11. So which calculation is easier? Taking all those things, summation height by 1000. So all 1000 students height we will add divided by 1000. So there will be how many operation? 1000 means 990 times we have to add the things, then divide by 1000. Here 1 to 11, 11 multiplication is there. Divided by then 10, 11 plus 10, 21, then something is there. So it will take less time. Here 1000 data, but there may be 1 lakh data, some things will be there. So that way if we find the things, it will be easy. Okay, in fact, we can write easily also. Suppose thousands height we have to enlist it. Then we can write this way also. Instead of writing whole 1000 students height, so say 5 height is 5 number of student. So height number of student, that way we can enlist. Say for 5 it is say M1 student, 5.1 M2 student, 5.2 M3 student, that way 6 number of students is M11. So that way also we can enlist the data. So enlisting the data is clear.
Yes, sir.
Yes,
That is
sir.
one of the way, but there are many ways. Okay, we will not go to that. Many things are there. So pictorial and tabular method. This is basically tabular method. We are writing in a table, although it has a specific name. So here many things are there. Stem and leaf display. We will not go through that. If you interested, you can go through the things. Okay. Mainly we will go through histogram. One thing. So do you know what is frequency?
Yes. All time thing is occurring.
How many times these things are occur? That thing is frequency. So here, what is the frequency of the height number of students of height 5 foot?
1.
M1.
M1.
5.1 M2.
M2.
That thing is called frequency. Okay. Now, so probability of a student of height 5 foot. What is that?
5 into M1 by 1000.
5 into M1 by
Total.
no. Height is I am talking about height is height of
M1 by 1000.
M1 by 1000. Basically M1 by
M1 by 1000.
1000 here. So M1 by M1 plus M2 up to M11. Correct or not? That thing is called relative frequency. Okay. So for a particular object, how many times it is occur, that thing is called frequency. And if we add all the frequency, that thing is called total frequency. So total frequency is m1 plus m2 up to mn, whatever it will be given, that is total frequency. And frequency by total frequency, that thing is called relative frequency. So what is relative frequency of 5.2? m3 divided by m1 plus m2 up to m11. Frequency and relative frequency is clear?
Yes, sir.
Yes, sir.
Okay. Do you know what is histogram?
No, sir.
Actually, plotting data this way means sometimes you have seen data written in this way. Means suppose I am writing one example. Say there are mm, 10 things are there. Suppose there are numbers, say 1 occurs 2 times, 2 occurs 3 times, 3 occurs once, 4 occurs 2 times, or 5 occurs, say once, 6 occurs once. Okay, so these data are given, means 1 occurs 2 times, 2 occurs 3 times, 3 occurs 1 time, 4 2 times. So what are the distinct number? 1, 2, 3, 4, 5, 6. Okay. One, two, three, 4, 5, 6. And the frequency, whatever frequency, we will put in the put as y, means in the column. 1 height will be 2. So up 0 to 1, we will take height 2 units. Say this is 1 unit, say this is 2 unit, say this is 3 unit. Then 2 occurs 3 times. This one. 3 occurs once. This one. 4 occurs 2 times. 5 occurs once. 6 occurs once. See, except from the data, from that we can write 1 frequency is 2, 2 frequency is 2, 3 frequency, 2 frequency is 3, 3 frequency is 1, 4 it is 2, 5 it is 1. So except from this data set, we can, from this graph also we can write. This thing is called histogram. That is constructed with data and frequency. Idea about histogram is okay?
Yes, sir.
Yes, sir.
So here maximum occurrence is 1. These three data. So from this we can get little bit idea about the data. So what is the maximum value, minimum value? Minimum value is 1, maximum value is 3. So we will get little bit idea about the things. Those things are defined here. See, in a discrete data set, the frequency of a variable x is the number of times that value exists. Means how many times this data is occur, that is called frequency. And relative frequency will be frequency divided by total frequency, means total number of objects. So a discrete data set is obtained by some observation. The relative frequency of a value x is the fraction or proportion of the time of the value occurs. So let number of times x value occur is m and number of observations in the data set is n. So relative frequency is m by n. So corresponding to x we will denote by fx. Then what will be the total sum of relative frequency? It will be 1. Correct or not?
Yes, sir.
Okay. Theoretically, sum of relative frequency of the value is 1. Actually, classical definition is coming from this frequency, relative frequency. What is relative frequency? That is nothing but the probability of the occurrence of x. See, relative frequency of x. What is that? That we are defining probability of the occurring of the value of x. Correct or not? See here, a set consists of 200 observations on x. 200 observation and on x the number of occurrence a college student is taking in this term. So if 70 of the x value are 3, out of 200, 70 of the x values are 3. So what is the frequency of 3? Frequency of 3 is 70. And relative frequency of 3 will be 70 by 200. Okay. So frequency, relative frequency concept is okay? Okay?
Yes.
Okay, sir.
Okay. So what is the total sum of the relative frequency?
Sir, 1.
1. But what happens? Sometimes it may not be 1 because whenever large number of data set is given, when we will find their find this ratio m by n, some numerical errors will be there. So that's why it may not be exactly equal to 1, but it is almost 1. Sometimes that things come due to numerical error. Anyway, so what is frequency distribution? A frequency distribution is a tabulation of the frequencies or relative frequency. So how will that? So a rectangle can be plotted at a point x fx with height fx. X is the value, fx is the corresponding frequency. Means so x fx or relative frequency, whatever we can take. So a rectangle can be plotted at the x fx with height fx and value x such that the area of the rectangle is proportional to fx of the value of x. So histogram is an approximate representation of the distribution of numerical data which was introduced by Carl Pearson. It was first introduced by Carl Pearson. Okay. Basically, how it occur that means how many, so frequency is number of times the data is occur, that is frequency, and if we add all those things that is called total frequency, and frequency divided by total frequency that is called relative frequency. And whatever data if we plot this way, then that thing is called histogram. Is this okay? What is histogram, frequency, relative frequency?
Yes, sir. Yes, sir.
Okay. Only you go through these things. Means in this note, histogram onwards you study, and before that this is page 1. No need to study stem and leaf display, but I will discuss that thing. Okay. So not I am not going to the definition, means whatever actual definition. Suppose some 4 digits number are there. How you can arrange it?
As Ascending order.
That's fine. So basically many way we can do. So suppose a 4 digits number is given. Many 4 digits numbers are given. So either we will take 1 digit at a time or 2 digit at a time. Suppose we are taking, say, suppose 5 digits number are given. Okay. So suppose we are dividing this into two parts. 3 digits right side, 3 digits left side. Okay. Then we will enlist all 2 digits left side. So that then we get some finite numbers, correct or not? Suppose this data set 6435, 64267131. That way many data are given. So how we can display the data? First we are collecting digit in 100 and 1000 position. Third and fourth. Third and fourth, what are the digits? 64, 65, 71, 67, 64, 65, 66. So many digits are repeated. Correct or not?
Yes,
Yes,
sir.
sir.
So that things we are writing here. 64, 65, 66 up to 72. Okay. Then whatever digit in the for 64 corresponding to what are the first and second position digit? 35. That is written here. Again 64 corresponding digit is 64. Then for this 33. Then see here 70. And no other for 64. Okay. So whatever it is in the third and fourth position, that we are writing first in ascending order. Then it is 65. For 65, it is 26, then 27, then 06, then 83, and nothing is there. So what basically we are doing here, see here how many data are given, but we are getting in a simplest form. This portion, left side of this bar, that is called stem, and right side of this, it is called leaf. That is stem and leaf display. So many way we can do here. So what are the procedure for that? See, consider a numerical data x1, x2, xn. For each xi conjugates at least 2 digits. Because stem and leaf, we divide whatever number in two parts, stem and leaf. So stem position is the means that is the 6435. So what is the leading position? Third and fourth. In fact, fourth is the more leading position. So we can take fourth one also. So select one or more leading digits for this stem value, and trailing digits becomes the leaves. So if we take suppose 6435, if we take third and fourth as stem, then stem is 64, leaf is 35. If we take fourth one as stem, then stem is 6, leaf is 435. List possible stem values in a vertical column. List all possible stem values in a vertical column. And record the leaf for each observation beside the corresponding stem value. Here, just right side that we are writing the stem value. And indicate the units for the stem and leaf someplace in the display. So here it is written 1000 and 100 digits. Stem is 1000 and 100 digits. Leaf is 10 and 1 digits. From that we can, what we can tell? Lowest digit is 6435. Highest 7209. That is the highest number. So which one occurs maximum times? 6700 means 67,000 numbers that things occur most of the time. So we will get little bit idea about that. So some idea is clear about stem and leaf display, just to sort out the data. We can take also, see, notice same choice, stem choice here of single is 6 or 7. If we take this one, means fourth position as stem, then leaf will be first, second and third position. In that case, stem will be here 6 and 7, 6 or 7, and remainings will be the leaf position. So if you interested, then you go to stem and leaf. Otherwise, you go through the basic definition, population, sample, variable. So bivariate, univariate, those things. Then most important things, frequency, relative frequency, those things, and histogram. Although this
Okay,
question,
sir.
hello, up to this okay?
Yes, sir.
One thing, this question is wrong actually. Find the relative frequency of each of the data 13483724723 and draw the histogram. Here what is wrong? Finding this relative frequency is wrong. 1348, how many data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data. So total frequency 11. 1 occurs once, frequency 1. Then 2. 2 occurs how many times? 1, 2, 2 times. 3 occurs 1, 2, 3, 3. 4 occurs 2 times. No 5, no 6. 7, 2 times. 8, 1 times. The relative frequency will be 1 by 11. Then for 2 it is 2 by 11. For 3 it is 3 by 11. 4 it is 2 by 11. 7 it is 2 by 11. 8 it is 1 by 11. But that calculation, some places it is wrong. See, total it will be 1. Here 3, 3, 6, 2, 8, it is 11. Maybe they have taken the approximated value, but better to write in fraction. 1 by 11, 2 by 11, 3 by 11. Whenever small data set is given, you write in terms of fraction. So here it is written 1. So that way it is written. Actually, most of the time it is written this way. How it is written? 1 occurs 1. So 1 with 1 center, we are taking both side half unit. Then it will be total 1 unit. Height is 1 here. 2 occurs 2 times. So from 1.5 to 2.5, we are taking height 2 units. 3 occurs 3 times, 2.5 to 3. See, no 6 is occur, so that's why height is 0. That way it is done. Up to this it is okay?
Yes, sir.
I have not shared this one, I will share this. Okay. So you go through mainly histogram onwards here, and before that you go through up to this. Sometimes mainly questions may come from frequency, relative frequency, those things. Basically, whatever classical definition of probability, that is nothing but relative frequency. Okay. Okay, I will share this. Jamboard is required to share or not? Because nothing is written here. Or I will share it.
Sir, you shared the notes, the book part.
Books is already shared chapter wise. If you see. Screen is visible.
Yes, sir.
So here is cover content. Chapter 1, 2, 3, 4, 5. This is from JL Dever book. So now we are in chapter 1. Only some definitions are there. So So for that we are following one PDF. I will upload it today. Whatever I am showing now means just now I am discussing the things. I will share that one.
Okay,
Okay.
sir.
And Jamboard link I am sharing in the WhatsApp group. Okay.
Yes.
Okay, sir.
Sir, please share the PDF and the notes, please.
PDF I will share whatever that one I will share it.
Okay, sir.
That thing is descriptive statistics. Although books is shared, but next class onwards I will share a handwritten notes. When is your next class? Maybe tomorrow, no?
Yes, sir.
This
Tomorrow.
Yes, sir.
Yes, sir. Tomorrow.
tomorrow we will start the probability portion. Means from chapter 2 because these basic definitions only are there. Okay, notes is shared. Wait, I will take attendance. And if you have